You have been solving equations with two equations, two variables. In math, we say two equations, two unknowns, right? Now, today, we're going to move into three equations, three unknowns. Three equations and three variables. Just so you know, for each unknown, for each variable you need to solve for, you need an equation. So if I had four unknowns, I would need four equations in order to solve the system. I remember years and years ago when I took linear algebra, the only thing I remember from that whole class was having to solve a system of 7 equations and 7 unknowns, and which was fun. That was an easy part. Like that's when you just like solving math problems, it's easy. So I loved that part of my math classes. Most of the time, you're just writing proofs. Anyway, all right. So every single group figured out that this was 0, 5, 2. So well done to all of you. But this took it easy on me. Because we gave you x plus y was 5. So you could just replace this x plus y with a 5. And you automatically get z equals 2, which is why most of you wrote z equals 2 first, right? Then you've got your, is that not what you guys did?
Yeah, well, that's what we did.
Oh, okay. Anyway, that's what I would have done, right? And then I would have, so then I would have replaced this z with a 2, and then solved this for like x or y and done some substitution. Solve for the other one, which is what I see on most boards, so well done. But we're going to take it up a little bit of a notch so that you can do it where there aren't any easy, fun, obvious methods for solving. All right, so today we're doing, don't worry about this vocab. We'll talk about it, but I don't want you to write everything down. Today we're doing section 2.6, which is called larger systems. Yes, yesterday we did 2.3. Today we're doing 2.6. It feels weird, but it makes sense. Tomorrow and Friday, we will be doing section 2.4. And then Monday and Tuesday, we'll be doing, tomorrow we might just do 2.4. And then Friday and Monday, I think we do 2.5. I'm not positive. I got to look at the calendar now. Anyway, we'll be covering 2.4 and 2.5 over the next few days. So 2.4 and 2.5 all deal with inequalities. So we figured we'd do 2.6 first, get all the equations done before we move into inequalities. Yes, Ishani, what's up? That is such a good question. Sorry, can I sneak another peek at your calendar?
Yeah.
Let's see. All right, so quiet down, please. Yep, tomorrow, we were going to do 2 days on 2.4. We chopped a day because we had to lose a day for ACT. So that was the day that we chopped. So we're doing 1 day in 2.4 and then two days in section 2.5. And then next week, Tuesday, there's school if you're a junior and no school for everybody else. So because it's ACT day. Next Tuesday, the 25th. So if you're a junior, you have school. All freshmen, sophomores in the room, no school. All right. And then Wednesday is a review day, and then your test will be on Thursday, the 27th. So in a week and a day. It's a week from tomorrow.
Okay. So it's next week?
Yeah. We're all right, test is next week, Thursday. Okay. Quiet, please. Plus, in this chapter, not only do you have a test, there's also a small project that will count for a test grade. So it's not a full test grade. I think it's 15 points. Don't quote me. I could be wrong. It might be 20. I think it's 15. So anyway, so there's a small project that we'll be doing that will also count as a test grade. You know what? I'm almost positive it's 15 points. And as long as you do it and do it correctly, you'll get 15 points, right? So yes. The project is individual. Good question. Yes. All right. So systems. And a few little notes of vocabulary which you do not have to write down. So linear system, we call these linear systems ax plus by plus cz equals d. We call them linear because all the variables are to the first degree, right? However, if you graph an equation, ax plus by plus cz equals d, you don't actually get a line. It's the graph of a three-dimensional linear system is not a line. Anyone have a guess what the graph looks like? If I graphed like 2x plus 3y plus 5z equals -6, what would the graph look like? I'm sure this is kind of big. I don't know. When you don't have any, when all of your variables, when the exponents are all 1, you're not going to curve. So it won't be a curve.
It's diagonal. It's really diagonal. Like, it's diagonal.
It's a plane. Yeah, very good, Grace. Yeah, it's a plane. So, so when you graph, when you add a z value on, and it's a linear system, the graph ends up being a plane. Now, you do not have to worry about how to graph a plane right now. It's kind of tricky to graph it. It's like practically impossible without a computer. My planes, when I have to graph them in Calc 3, they look terrible. They're awful.
What
so
does a
anyway,
plane look like?
a plane, so a plane is a flat, pretend that it's a flat surface that extends in all directions forever. So, like, here.
So it's like scribbles.
Here, I'll show you. All right, here. Let me show you. Okay. All right. So, a plane. So, if I graph 2x plus 3y plus z equals 5, that's what a plane looks like. It's like a sheet that extends in all directions.
Yeah.
Okay? Now, if say this is my plane, right? Shh, quiet, please. Now, suppose I went ahead and added another plane. So let's do x plus y plus z equals -2. Oh, I want this a different color. Let's do like blue. Okay, so now close, goodbye. Okay, goodbye. Let's see now. I need to zoom out. There we go. So what happens is when you have a plane and another plane and you look and see where they cross, the place where they intersect, what graph does it form where the two planes crisscross each other? What shape is that? It's a line, right? So if you have a plane and another plane and you look at where they intersect, what you end up with is a line. Now, if we add a third plane onto this, so for example, suppose I just graphed x equals 2. Okay, if I add a third plane onto this, right? So now I have 3 planes. They intersect, so these two, any 2 planes intersect in a line, but all 3 of them together intersect at what?
Point.
It's just a point, this point right here. So when you have 3 planes that intersect at just a point, then that point is the solution of your system of 3 equations, right?
More than 1 point.
So if you're either, okay, so good question. If you have a system of 3 equations with 3 unknowns, they're either going to intersect at 1 point, or let's change this one to be, okay, I'm going to retype this. So 2x 3y plus z equals 2. Oh, wait, let's make it a bigger difference. -1. And then this guy, 2x plus 3y plus z equals -10.
All right, let's zoom out, or let's see, zoom in. All right, these three planes are what we call parallel. So these planes, if I were to solve this system, how many solutions would they have? 0, right? They're parallel planes. They'll never intersect. So if you have three planes that are all parallel, then they're going to have 0 solutions. So if you have planes that are all different, they're going to have 1 solution. Parallel, they're going to have 0. If you have 3 planes, 10, 10. Wait, what just happened? Did I type something wrong? 2x plus 3y plus, oh, whoops, I typed a negative 10. 3 planes, but they're all the same. How many solutions are you going to have? Infinitely many, right? Those are really your only options. You can have like 2 parallel and 1 that's not, and have them like these 2 will meet in a line and these 2 will meet in a line. But to have all, if it's a solution that has to be true for all 3 planes, it's either going to be 0, 1, or infinitely many. So, all right, that was definitely better. Like 3rd period, I tried to demonstrate that by holding up 3 whiteboards, and it got quite convoluted. So using that's where technology can be our friend, right? All right. Okay. So these are called linear equations, but the equations are not lines. All right. Here's the thing: the most important thing that you're going to see me or hear me say a lot today is ordered triple. So the solution to a system of 3 equations, 3 unknowns, is going to have an x, a y, and a z. Because it's going to have an x and a y and a z, your answer is not going to be an ordered pair. It's going to be an ordered triple. So like this guy right here, we would write this as 0, 5, 2, which is a point in what we call 3 space. A point if we had an x-axis, a y-axis, and a z-axis, which I'm going to show you in a second. So anyway, so an ordered triple just means it's an ordered set of 3 components, not just 2. All right. I keep making this small. All right, again, you don't have to write this. Graphing points in 3 space is it's really hard. So it's easier to graph a point than a surface, but it's still tricky. So, and part of the thing that I don't like about points in 3 space. So most of the time in 3 space, when we're in 3 dimensions, so we have an x-axis, a y-axis, and the z-axis now goes up and down. So obviously, this board is 2 dimensions. It's flat, right? So how do you draw something that's 3-dimensional on a surface that's only 2-dimensional? So the x-axis, we think of the x-axis as coming out like this. And then the y goes sideways and the z goes up and down. So that's how we picture it, is visually it would actually be like this. X coming out, y going this way, z going this way. But to draw it on a flat surface, we turn the x-axis like that to kind of give it like perspective, right? Or that perspective drawing where you kind of tilt things to imply depth. No? No, right like that. Okay. So anyway, now, how do we sketch a point? Well, if I have to plot the point 3, 4, 5, that means I'm going to go out 3 on the x-axis, over 4 on the y-axis, and up 5 on the z-axis. 3, 4, 5, and that gives me that point. So you just follow the numbers on each axis. I go out 3, I go over 4, I go up 5. However, if the point isn't labeled, say I just put a point right here, would you have any idea what point that was?
No.
Because it could be infinitely many possibilities. It could be anything, right? We have no idea. For all we know, that point is -3, 2, 5. It could be 0 to 4, right? right? We have no idea. So normally when we plot a point in 3 space, if we don't write the ordered triple, then we show kind of the path that it took to get there. And that way people can say, oh, okay. Because we don't even know which now we don't have quadrants in 3 space, we have octants. There's 8 of them. But we don't even know which octant is in if it's just a point just sitting there. So you have to kind of draw the little lines so that people can see. But you don't have to worry about that because we're not going to ask you to do that. So anyway, however, this is just to kind of tell you that a point, that when you get an answer with 3 numbers in it, that those numbers mean a point in space somewhere, right? Okay, good. The thing that I love, and this is why I keep pushing Calc 3 all the time, is because the world is in 3 dimensions. So until you get to 3 dimensions, there's still a lot of applications you can do with math, but there's so much more once you add a 3rd dimension to it, right? So now all of a sudden we can actually move through the world, not just in, have you ever read the book Flatland? Anyway, yeah, everything's in 2 dimensions. No? Oh, okay. It's kind of funny. Like if you think about it, if you all lived in 2 dimensions, right, and you're standing there, like here, I'll draw you as a stick figure. Right? And then someone next to you is standing next to you, and they want to go on the other side of you, what are they going to have to do, right? They're going to have to like jump over you to get there. Yeah. Anyway, kind of fun stuff. All right. Wow, we haven't even started the lesson yet. Okay. So I normally do not like to give steps. I don't like to give steps normally because I think that they take away from real mathematical thinking and reasoning. However, when you solve a system of 3 equations, it's really easy to go down a rabbit hole and find yourself with like a whole page of work and no answer. So in order to help you avoid the rabbit hole, I'm going to give you some steps. Is that okay? Okay. All right. Yeah? Okay, Ryan, I don't want to take away, like, I don't want you to think that I don't think you're a good mathematical thinker by giving you steps, right? Do you feel that? Yeah, okay. That I believe that you are a good mathematical thinker? Yes, okay. All right. Okay. So here's the thing. Step 1. You're going to pick 2 equations, and you're going to get rid of one of the variables. Doesn't matter which one, doesn't matter which equations, doesn't matter which variable. You just pick 2 equations, you pick a letter, and you eliminate it. That's fine. Anybody can do that, that's fine. But then the step 1 subpart B, you don't need your laptop right now. The next part, this is the critical part. You have to pick 2 different equations and eliminate the same variable. That's the part that gets people. So if the first 2 equations I pick, if I eliminate my y, then the next 2 equations I pick, I had better eliminate y again, or I'm now in the rabbit hole. All right? We don't want to be there. All right. So the way that this is worded, work with pairs of equations to get the system down to 2 equations with the same 2 variables. Doesn't matter which 2. It could be x and y, it could be x and z, it could be y and z, doesn't matter. But they got to have the same ones. So if you eliminate the z's the first time, you got to eliminate the z's again. Once you get them down to 2 equations with the same 2 variables, now you're back in the world that you were in for the last week. And then you could just use substitution or elimination or whatever you want, and you just solve the system just like we've been doing for the last several days. Okay. Once you have these written, we'll move into our first example. I am actually going to kind of walk you through the first example, and then I'm going to have you guys do some on your own. Noah, how's it going? Are you taking a picture of the notes?
Yeah.
Okay, that's fair. You know that these are online. But that's okay. You can take a picture too. All right. All right. Feel good? All right, so for first one, oh, don't look at this. I gotta delete that. I keep forgetting to delete that line. You didn't see that. Okay. So I will tell you all day when I talk about my three equations, I'm going to identify them by top, middle, or bottom. All right? So top, middle, bottom. Everyone with me? Okay. So as a class, what variable do you think would be the easiest one to get rid of first? Oh, that's good. There's a lot of opinion on this. Okay, I would go with Z, but you could go with X if you wanted, right? Y would be the most difficult because you got three different leading coefficients for Y, but I would go with Z. Why would we pick Z? Oh, because remember when we're solving by elimination, you want the same coefficient with opposite signs. And since we already have a negative Z and a positive Z, these are just like already set up where we don't have to do any work to add them together and get them to drop out. Does that make sense?
2 out and do 2 of them and then another 2 including the last one, but one of the same ones?
I don't know if I understood your question. Follow along and we'll see, okay? Okay, so we're going to start, I'm going to rewrite the first 2 equations. You don't have to rewrite them. I'm going to rewrite them just so that you can see it more clearly. So we're going to do the top and the middle. And I want you to add them together. So take 10 seconds, add these together. Be careful with your positives and your negatives. Marcus, how are you? Good. I didn't mean to scare you. There wasn't a criticism. It was a legitimate question, like, how are you? Is your day going well? Yeah. Okay. Hi, Ronan. How are you doing? Are you?
Yes.
You had a good day? What was the best part of today? Yes! Holy cow, that's wonderful. Okay, good. How many X's do you get when you add these together? You get 8 of them, right? How many Y's do you get when you add these together? 2. And then how, like, oh, I didn't even ask, how many Z's? 0, they're gone, right? Okay, what's the number when we add these together? Negative 20. Good. All right. Well done, Ronan. All right. So now, okay, we have added 2 equations and we've eliminated the z's. We did the top and middle. Now we have to pick 2 different equations and eliminate the z's again. It can either be the top and the bottom or the middle and the bottom. Doesn't matter. It's whichever 2 you like the best. Michelle, you okay? Okay. So whichever 2 you like the best. So you tell me. So let's see which
Top.
top and bottom. All right, I'm hearing top and bottom more than anything else. If we add the top and bottom and we have to eliminate the z's, what would we have to multiply an equation by?
2 at the top.
Multiply top by 2. Does everyone understand why? Right? Because then we would have a negative 2z and a positive 2z and they'd go away. So I'm going to multiply, I'm going to write times 2. All right, so I'm going to multiply the top equation by 2. And then I'm going to multiply the bottom equation by nothing. I'm just going to write it down. 2x plus 2y plus 2z equals 8. All right. Isaac, how are you?
Good, how are you?
Oh, I'm doing great. Thank you for asking. So how many x's do you get when you add these together?
6.
6 x's. How many y's? Beautiful. How many z's? None. And then, ooh, negative 34 plus 8. Oh, okay. Jesse's helping him out. Okay, that's okay. Well done. All right, good, Jesse. Good mental math, right? Okay. All right. Are we all together? So we picked 2 equations, eliminated the z's. Picked 2 different equations and eliminated the z's again. We all good? Sophia, you good? Okay. All right. Now we have 2 equations with 2 unknowns, which means you can solve these either by substitution or elimination, whatever floats your boat, right? So I want you to take a minute, solve these 2 equations, the system of 2 equations with 2 unknowns, either by substitution or elimination. Take a minute and do that. He's like raring to go with his math today.
Oh yeah.
All right, so quiet down, please. So did you choose to solve this by substitution or elimination?
I use substitution.
Use substitution. Okay, so what variable did you solve for?
I solved for y. No, I did x.
You solved for x. Okay. Okay, so you have.
No, wait. I did y. I got 2.
Okay. Oh, wait. So you didn't. Did you do substitution? Are you sure?
Jesse.
Or did you do elimination?
Well, because you just subtract.
Tell me what you did. Walk me through.
The first thing I did was, so for the first equation, which is the one on the left,
Yeah.
I just subtracted 8x.
Okay.
This other side.
So you solved for what?
Solved by, and then I used substitution. And then I divided everything by 2. And then I just plugged that in for both.
And then he substituted that in for the y in the other equation. Solve for an equation for one variable, substitute it into the other.
I didn't realize you could do that. I always had to put them equal to each other.
Ah, nope, you can just substitute it wherever it's sitting. So times negative 10 minus 4x is negative 26. Is this what you did? Yeah. It's getting like quite chatty here. Okay, subtract 40. What's negative 26 minus 40? Okay, ignore, we're not going to shut it. Okay, x equals negative 3. So if x is negative 3, how do I find y? Plug it in. Y equals negative 10 minus 4 times negative 3. This is plus negative 10 plus 12, which is 2. I've got x, I've got y. This is called back substitution, in case you're curious. This process, when you kind of solve forward and then back substitute backward. So we kind of work our way up and keep substituting until we got everything, right? So x is negative 3, y is 2. So I'm going to just use, I don't know. Did you use the top, the middle, or the bottom?
I used
I didn't do that way. I did elimination.
Does it matter?
well, not really.
That's right. Which one do you like? Is that, are you 17?
Yeah, negative 17.
No, I was asking if you picked it because you were 17 years old. Oh, I'm sorry. Well, I didn't mean to be offensive.
No.
Okay.
I'm not offended.
Okay. 2x minus 3y minus z equals negative 17. So 2x minus 3y minus z. If I saw an equation with my age in it, I would pick that one. Right? Makes it personal. Okay, so we have negative 6 minus z equals negative 17. So negative 12 minus z, negative 17.
add 12. What's negative 17 plus 12? Negative 5. Divide by negative 1, so what does z equal? 5. So now, our solution is an ordered triple. Go ahead and write this in. I think I'm going to move this down a little bit. So you go negative 3, 2, 5. There's our solution. Find this. Nail it. Johnny, did you nail that? All right. Nithya, did you nail it? Did I say your name right or wrong still? But it's Nithya.
Yeah.
I got the skya. But I said knee instead of nit.
Yeah.
Okay. All right. Have you ever seen Monty Python? The 1980s? Okay. I have another one for all of you to try. You're going to do this start to finish on your own. Remember, you can pick any two equations and whichever variable you want to eliminate. Then pick two other equations and eliminate the same variable. I'm going to pause.
Is this going to be like
Going with Z. So I'm assuming you did the top and middle first. Okay, so you get 4x plus 3y equals 5. We good so far? Okay, pick two other equations. We did top and middle, now what? Middle and bottom? All right. So Paxton, what did you do so that the z's would drop out again?
I multiplied the top by negative, or by 2.
The middle by 2, right? Yep. So you got 6x plus 2y minus 2z equals 4. 2x plus 3y plus 2z equals 7. Add down, how many x's?
8x.
How many y's? 5y. How many z's?
0.
Equals 11. Okay. All right. By the way, just in case you're wondering, what were the magic equations that made your life easy if you did them? Did anyone do top and bottom? No? Yes? Okay. Yeah. If you did top and bottom, multiply the top by negative 2, the x's and the z's dropped out, and you got the answer for y like that. I know. It was really nice, right? But that's okay. All right. So now, we have two equations. So, Paxton, did you do elimination or substitution?
I did elimination.
That's what I would do too. So, did you multiply this equation by something?
Negative 2.
Times negative 2. So, I'm going to write times negative 2. So, negative 8x minus 6y equals negative 10. Add down, you get negative y equals 1. So, y is negative 1. How are we with the y equaling negative 1? Yeah? Feel comfortable with that? Jay, how you doing? Good? Okay, good. All right. So y is negative 1. To find x, I could plug that negative 1 into either this one or this one. Don't go up there because I can't find x if I've got 3 unknowns. But pick one of the two equations, 2 unknowns. So 4x plus 3 times negative 1 equals 5. 4x minus 3 equals 5. 4x equals, add 3 to both sides, 8. Divide by 4, x is 2. So now I've got my x, I've got my y, I need a z. I'm going to plug into the top. You can plug into any one you want. I think the top looks easiest. Do you agree, Marcus? Yeah. Okay. So what did I get for x? 2. Okay, x is 2, so I have 2 plus 2 times negative 1. 2 plus 2 times negative 1 plus z equals 3. Equals 3. Hey, look, I get 2 minus 2 plus z equals 3. So z equals 3. So how do I write my answer? What do I call that thing that I write? An ordered triple, right? 2, negative 1, All right, I want to see on your hands from a 1 to 5, 1 meaning I am so lost, I like truly feel like crying, and a 5 meaning I totally get this, right? Let me see where we're at right now. Okay. Okay. All right. Marcus, I don't see any figures. There we go. Okay. Okay, I'll take that. All right. Really? No, it's okay if it is. Are you joking? Okay. All right. Okay, good. All right, so we're in good shape. Let's do another one. Actually, I'm going to skip this one for a second. So we're going to do this one. I'm going to mess with you. Just start this one. See what happens. Just try it. That's okay. You won't need a lot of paper for this one. Okay? So, all right. What letter did you guys pick to eliminate? X. Okay. So did you do the first 2 equations?
Yeah.
Okay. So, Tori, what did you multiply the first equation by?
-2.
-2. So tell me what you get when you multiply.
-4x plus 4y minus 2z equals -14.
That was really fast. All right, good. And then you write the middle equation. Whoops. -4y plus 2z is 17. And you add down. How many x's?
0.
How many y's?
0.
How many z's?
0.
So what's left on the left-hand side?
0.
0. What's on the right?
3.
So there's no solution.
Very good.
Yeah.
Very good. So does 0 equal 3? No. Last time we checked, no. Right? This is 5, please. This is what's called a contradiction. 0 cannot equal 3, right? So when you hit something that is never true, this thing is, I can't write the word true. That says true. Never true. When you hit something that's never true, that means this system has no solution. Now, the other 2 equations might intersect at some linear equation, but there's nothing that all 3 of them are going to have in common, right? As soon as you hit a contradiction, you can just stop and say, hey, this system has no solution. If you have a system with infinitely many solutions, instead of getting something like 0 equals 3, you would get something like 3 equals 3. Something that's always true, right? So you have no letters in there. You just have, like, I just added these together and got 3 equals 3. What on earth does that mean? That means this thing is true no matter what you plug in. It's got infinitely many solutions, right? So you either have an always true for infinite, a never true for none, or what's most common, which is you end up with a point. Right? Okay, that's it. So that's all we're going to do. There is a word problem. Should I show you the setup real quick for the word problem?
No.
You might want to see it because I think there's at least 1 or 2 in your homework. Okay, let's do a setup, okay? But you can, if you want to sit back and watch and take a picture, or if you want to write down the whole thing, that's up to you. We have $30 to spend on picking 24 pounds of 3 different types of fruit at a farm. Apples are $1.40 a pound. Blueberries are 90 cents a pound. Cherries are $1.10 a pound. You want twice as many pounds of apples as your blueberries and cherries combined. We need to take this information and write 3 equations. So when you have your totals, that kind of helps guide you with what equations you're going to write. So first we have $30 to spend. That means the total money that we spend on apples plus blueberries plus cherries has to equal 30, right? Okay. How much, if I call, let's just call apples A, blueberries B, and cherries C. Look how nicely that worked out, ABC. How much would I spend on apples if A is the number of pounds of apples and they're $1.40 a pound? $1.40A. Did I say Grace? I just yelled it out. So that's what she said. So she's absolutely right. 1.4. If I buy, like for example, if I buy 2 pounds of apples, I've spent $2.80, right? Okay. All right. So that's how much I spend on apples. How much am I going to spend on blueberries? 0.9B. And then how much am I going to spend on cherries? $1.10.1.1C. And what's the total amount I want to spend? $30. All right, so there's my money. The next total I'm given is pounds. How many pounds of apples am I buying? Don't overcomplicate, it's really easy. You're right, it's A. Okay. How many pounds of blueberries am I buying? B. How many pounds of cherries am I buying? C. What's the total? 24. All right, I have 2 equations, but I have 3 unknowns. How many equations do I need? 3. Any other information given?
Twice as many.
As the other 2 fruits combined. All right, so here, let me. Go away. Okay. It didn't delete. I don't know. I'm stuck. Okay. So I want twice as many apples as the other 2 fruits combined. All right. The other 2 fruits combined, that. Come on. Whoa. Woo! There we go. I'm just going to delete all this stuff. All right. So the other 2 fruits combined would be B plus C. Apples would be A. Where does the 2 go?
Under.
Why?
Because it's twice as many as B and C.
Because if I buy 9 pounds, if like my B plus C, blueberries plus cherries is 9 pounds, how many pounds of apples do I want? 18, double, right? So I have to times the B plus C times 2, not the A times 2, right? Right? Okay, so there's your 3 equations with your 3 unknowns. This one you would probably want to clean up a little bit. So maybe subtract the A and distribute the 2. Right? Something like that. But anyway, there's your 3 equations. And then you can go from there because you guys are so good at this. All right, I am going to stop right there.